Thank you so much for coming to this special ACAN Passivhaus Mythbusting event. My name is Sara Edmonds and I'm a coordinator here at ACAN, and I'll be your host for a small amount of this event this evening. I'm sure a lot of you are familiar with ACAN and even active within the network, but for those who missed it, ACAN is a network of individuals within architecture and related built environment professions, and we are taking action to address the twin crises of climate and ecological breakdown. If you would like to know more and get involved, please visit our website at architectscan.org. To give us a chance to settle in, I'll run over a few technical points and get them out of the way. So your microphones will be kept muted throughout the event. Your video is automatically turned off, but feel free to turn it back on. Just be mindful that we're recording the event, so just keep your video on if you're comfortable with that. Please introduce yourselves in the chat box, which I can see lots of you are doing now, which is great, and ask questions throughout. If we don't get to answer all your questions, our speakers have kindly agreed to answer them, and we'll share those answers after the event. There's a lot to get through tonight, including my own technical problems at the start. So if we run over, we'll try and keep it to an absolute minimum. And thank you again for your patience. We're going to share a poll now to get a sense of who is in the room. What's your experience and opinion of Passivhaus? So if you could all fill that in now, and then we can share the results. Yeah, so the purpose of tonight's event is to take the most commonly known myths about Passivhaus and attempt to bust them. Some of you may recognise our wonderful chair, Hattie Hartman, sustainability editor at the Architects Journal. Hattie has also been running a series of podcasts with George Morgan called Climate Champions, and I would highly recommend that you give it a listen. We've got three excellent speakers lined up to inform and inspire us, whom Hattie will introduce further. And to begin with, each speaker will take three of the most common myths in turn, or thereabouts, and elaborate and educate us on them. Following this, we'll have a panel discussion with all three speakers based on broader questions around Passivhaus. We'll share a poll again at the end of the event to see maybe how opinions might have changed. And yeah, we look forward to an informative and lively discussion this evening, and afterwards invite you to our virtual pub, The Hope and Action, for a more informal chat and maybe even a drink. So I'll pass to Hattie now, who will chair the discussion. Thank you very much and enjoy.
Good evening, everyone. And thank you to ACAN for asking me to chair this event about Passivhaus myth-busting. This is a really important discussion, and I would venture to say it's overdue, and it's great to see so much interest. I can see from the poll that there are a lot of people who are fairly new to Passivhaus, which is great because we have a really expert panel to clarify a lot of the kind of myths that keep flying around. So our panel will share their insights with you and dispel some of the common misconceptions about the Passivhaus standard, and then answer those questions you've always wanted to ask for those who are more knowledgeable. Each speaker has been assigned three common myths, as Sarah said, and has 10 minutes to discuss and rebut them. We'll hear the three speakers in turn and then open up for questions. I anticipate lots of questions, and I have some of my own, so we may run slightly over. I will endeavor to wrap things up by 8:15, and then we can meet in the virtual pub if you want to continue the discussion. Please put your questions in the chat continuously as they come up so that we can. As I was thinking back about this, I first heard about Passivhaus in 2007, shortly after joining the AJ, when I spent a press day at the BRE in Watford. And that same day, I also learned that a UK chapter of the Green Building Council was about to launch. Soon after, I was fortunate to be invited on a UK GBC study trip to Hamburg to look at Passivhaus buildings. And it was a super interesting trip with a lot of not particularly appealing buildings. I really wanted to share some images with you tonight from an article I wrote at the time, but this was pre-digital And I've not been in the office to access the bound copies of the AJ and dig this out. Once I was back in London, I started asking around to find any architect who knew anything about Passivhaus in 2007. There were very few. I was immediately directed to Justin Bear, and he, until the Passivhaus Trust was founded 3 years later, almost single-handedly put Passivhaus on the map in the UK. And if you haven't seen it, I really highly recommend his excellent book, which is beautifully illustrated and includes a lot of interesting examples from Austria and Germany and Switzerland. Maybe someone can put the reference in the chat. About the same time, I came across Archetype, and they were just getting into Passivhaus. And then along came John Bootlin, who set up the Passivhaus Trust, which celebrated its 10th anniversary last year. John kindly invited me to take part in the Passivhaus Awards jury several years running. And the Passivhaus Awards were and are distinctive because of their evidence-based criteria. It was absolutely not a beauty contest, but many of the projects really didn't measure up visually. And we had a lot of very heated, or should I say overheated, discussions with Nick and others at the time. In my early days at the AJ, when I ran the Footprint blog, at one point I decided to track all the Passivhaus projects in the UK with a digital map. Today, that would be a no-brainer, and an ACANer would do this in an hour. It was quite labor intensive at the time. And then in 2019, as you all know, Michael Ritchie's Goldsmith Street in Norwich won the Sterling Prize, putting Passivhaus front and center on the industry's radar. Now, during lockdown, we have a new Passivhaus podcast, which is, I think, broadcast simultaneously from New Zealand and Seattle. I saw that there was someone from Oregon in this meeting and someone from South Africa. There's also international Passivhaus drinks online. I don't know if any of you have been to that. I haven't. But so in a decade, Passivhaus has ramped up from the first Passivhaus in the UK and Wales in 2009 to Goldsmith Street in 2019. And there are several 100 plus unit local authority schemes in the pipeline now, including some very promising ones in York by Michael Ritchie's. This shows what can happen in 10 years, but we need to accelerate massively in the next decade to meet the 2030 targets. So the question is, what role should Passivhaus play? And we'll discuss that more in the panel discussion. Let's turn to our first speaker, who is Rebecca Robinson. She's an architect and certified Passivhaus designer at Archetype, where she has worked for nearly 5 years. She led the Bicester Eco Business Center project, the first Passivhaus Plus non-domestic building in the UK. She's currently working on both Passivhaus schools and residential projects. She's gonna bust 3 myths for us. Rebecca.
Great, thanks, Hattie. Let me just get my screen set up. How does that look for everybody?
Perfect, thanks.
Good.
Great, so yeah, it's great to be here tonight, and as an architect who only designs passive houses, it's really great to be able to bust these common myths, as there are a lot of misconceptions out there about passive house, which can get a little bit frustrating for us sometimes. To start with, you can't open the windows. Quite a common one, but you absolutely can open the windows in a passive house building. And Archetype, we always design in opening windows to all the habitable rooms in the building. But unlike a standard building, you no longer have to rely on having windows as your only source of ventilation. The building is designed to have plenty of fresh air from the ventilation system to keep you healthy and comfortable, but opening the windows is also encouraged for supplementary vent and night cooling in summer. It's really important for occupants to feel in control of their space by being able to open the windows. And our post-occupancy evaluation backs this up. So speaking to teachers in schools and residents of housing, they all like to use the building a little bit differently and have that flexibility. And opening windows is such an important way of the part of the way that we design, that we often design in these secure metal grills on the outside of opening windows, so they can be left open overnight without worrying about security. They're quite good as a part of the passive cooling strategy. In the height of summer, when it can get quite hot, it's useful to leave those windows open at night when the temperatures are cooler outside, to help cool the building so there's no overheating. And the beauty of Passivhaus is that you get this perfectly functioning, comfortable, healthy building as a baseline, and then the occupant is in control of how they use it. Whereas in a standard house, you sometimes might need to open the window to ventilate the bathroom. Even when it's freezing outside, you've got drafts, you've got high heating bills if you want to stay warm. The building is in control there. Whereas in Passivhaus, the occupant is in control. And that's just what those grills can look like from the inside. So since you can open the windows, Passivhaus is obviously are not hermetically sealed boxes. Air does come in and out. We've had no reports of our clients suffocating so far. However, the fabric of the building does need to be airtight, down to about 6.6 air changes, which is about 10 times lower than current building regs. This is a good thing. It stops all your heat escaping out through holes and leaks in the building, and it stops there being uncomfortable drafts inside. And that airtightness figure is tested with all the windows, doors, vent systems shut. But then when people occupy the building, you get fresh air through the vent system, as well as having windows and doors open. Just to flag up, airtightness is not the same as breathability or vapor permeability. And you can build a Passivhaus out of anything that you want. Archetype, we prefer to design airtight buildings that are also breathable and use natural materials. And we tend to use OSB on large projects as the airtightness layer, quite cost effective, no wet trades, and it's proven to work. But you can also use a render particle if you wanted to go a bit more natural. A nice example of a house that I would love to live in, or a colleague George, looks like a great place to live. Also bust that myth that you can't have large amounts of glazing in a Passivhaus. Windows again. The type of windows that you need for a Passivhaus are well insulated frames, they're triple glazed, they've got high performance spacer bars and a really high air tightness class. So this generally means that they're of a higher quality and much less likely to fail than your standard alternative windows. The installation quality is also a lot better in a Passivhaus, as it's actually tested by the air test result, which forces installers to do it correctly. The windows are also protected by a deep window reveal most of the time, which is used for shading, meaning less weather exposure to those windows. And Passivhaus being a comfort standard as much as an energy standard, from these windows, you're getting comfortable, even temperatures everywhere in the building, not that really cold feeling when you're sat by the window and you can feel it radiating. There's no mold or condensation on your window frames. So moving on to MVHR.
Like, I think you're going to have to go a little more quickly through the next two.
Oh yeah, the other two are
okay.
So it does work, and we wouldn't use it if it didn't. Of course, it is still a bit of machinery, can't be 100% reliable, but no one says boilers don't work or cars don't work, because they very occasionally fail when not maintained properly. For those that don't know, MVHR units extract warm, stale air from spaces like your bathrooms and kitchens, and on its way outside, run it through the heat exchanger, taking the heat from it into the fresh incoming air. So you've got fresh air in all the spaces that you need it all year round, and having that really good constant and high air change rate removes excess CO2, humidity, indoor pollutants, and your incoming air is also filtered. So you've got a much healthier indoor environment, which is high on everyone's agenda at the moment. So like natural ventilation does sound lovely, but if you call it random uncontrolled ventilation that's cold, it doesn't sound so great. And mechanical ventilation is actually a constant supply of pre-warmed fresh air, which sounds lovely, and it is. Very quickly going through these, there's no recirculation, it's always fresh air. You shouldn't get dry air if the system's designed correctly. The unit should be actually quieter than a household fridge. Shouldn't generally fail if designed and commissioned correctly. Most of the reports I've had of problems with MVHR from buildings with Passivhaus principles. So not using high quality units, and the commissioning isn't picked up by a certifier as it is with actual Passivhaus. They don't use that much energy, less than £3 a month for a house, again, less than a fridge. And they don't really need that much maintenance, though they do need some. You do need to change the filters. And that's what they look like after 6 months. So I think it is a task worth doing to stop you breathing in all that gunk.
Okay, one minute, Rebecca. Sorry, we've got to keep to time.
No worries. I'll just quickly bust this myth of it's only for houses. Definitely isn't. Archetype, we do so many non-residential buildings. This is one not by us, but quite high profile. First Passivhaus swimming pool. We've done these a couple of schools, also going to include pools. From apartment blocks, archives, office buildings, universities, secondary schools, and primary schools. That's it for me.
Thank you very much. It's really quite a body of work that Archetype has built up over the last few years. Our next speaker is John Palmer, whom many of you will have heard. He joined the Passivhaus Trust about 3 years ago as Research and Policy Director. And I've heard John's presentations. He's passionate and clear advocate of Passivhaus. He's a certified Passivhaus consultant, a SAP assessor, systems engineer, and experienced project manager. And prior to entering the construction sector, he spent 16 years as an engineering officer in the Royal Navy. John, over to you.
Great, thank you very much, Hattie. Hopefully everybody can see me, mini-me, and the slides. So we'll get straight on. I've got, it's too expensive, it's only about energy, and it's not for retrofit to deal with. So let's start off with it's too expensive. So how expensive is expensive? Well, you can see back in 2015, some of the worst projects were maybe around 50% in some cases, and those are the ones that some people like to remember. But when we did our latest analysis in 2018, you can see that that came down to 8%, and we're now projected to get down to 4% in steady state, and that's what's been seen in some other countries as well. So 4% doesn't seem too bad. What do we get for that? Well, this is where those extra over costs lie, and there are some things I just want to sort of pick out in here. The first one is if you're putting more insulation in, then it's no huge surprise that you're paying a little bit more for that insulation. Obviously, you're getting the performance aspects as well. MVHR, is that an extra? You're actually getting a different, better, much more enhanced form of insulation. Form of ventilation to your building, which isn't there in a conventional building, and delivers health and well-being to other things I'll mention in a moment. So actually, that's an upgrade, not an extra, I would contend. And then finally, we've got supervision, quality assurance, and that's what makes Passivhaus deliver what it says in the tin. It does, as the modelling suggests. And actually, is that Passivhaus an extra over cost for Passivhaus, or should we be doing that anyway on all our projects and delivering quality assured buildings?
This is a great slide.
And it's not just about your build costs. Once you've built it, you've got lower running costs as well. So this is your heating costs for a 90-metre square dwelling with an air source heat pump, £470 for a building regs compliant version, £83 for your Passivhaus. That sounds quite attractive. And really the way I like to sort of pitch this really is that this is kind of what we've been building for quite some time. If cars were houses, it's the same technology that we've been using for 50, 60 years. And we dress it up to look a little bit different sometimes, but it's kind of the same. And the performance isn't great, on paper, and in practice, it's sometimes even worse. What you can actually get is you can get something like this, which looks a lot better, but crucially performs a lot better. It's just 4% more, as we've heard, and the running costs are a sixth of your average new card. So which one would you buy? Finally, it's also important to look at the cost of not doing it and what we might have to do in the future. We know that we are going to have to significantly improve the efficiency of our buildings at some point before we get to 2050. So if we don't do it now, we're going to have to retrofit. If we add, this is figures from the UK CCC, if we build to effectively passive house standards now, 15 kilowatt hours per meter squared, that's an extra 5k on the build cost they estimate. If we have to retrofit that same building later, the day after it's finished, 26k. We need to put passive cooling measures and passive stop some overheating mechanisms in. That's 2k at new build. It's 9k if we have to do it later. So there's a cost there to not doing it in the future as well. Next one, moving on to it's only about the energy. Well, no, it's about a number of things. So the first thing is it's about comfort. And having been a passive house consultant for a while, people start to come to you about passive house and want to talk about the energy. When they move in, they don't want to talk to you about the energy. They want to talk about the comfort, what it's like to live in that building, how great it is, the atmosphere, the comfort, everything that goes with that. They actually forget about the energy and their bills at that point, and it's the experience of living in a passive house. It's also about health. I've got some, I'm just going to from Rebecca's pictures of dirty filters there. There's one on the left, a clean one on the right. That's 3 months after it went into my MVHR system. So all that pollutant would have come into my building. And I'll just let you read these statements because they're actually quite sobering. Particularly the middle one there, indoor air pollution, not what happens when we go outside, what we do inside our buildings, inside our homes all the time. So it's about comfort, it's about health. And the comfort and health issues, if you look at the passive house criteria, I haven't put the numbers in here because they're not relevant today, but all those items on the left, there are specific criteria that you need to hit to be able to call your building a certified passive house. And you can see that the majority of them are not actually energy related, they're comfort and health related. And that's where the standard has come from. And yet we do very well on energy as well, but it's actually comfort that leads the way. And the final point I'd like to make on this section, this particular myth, is it's also about performance. So we've got a couple of charts here from a passive house sort of temperature. So the top line there is the internal temperature in the month of December. Not much variation there, whereas the bottom line is the external temperature for that same building. So you can see that you get constant warm internal temperatures, even when it's freezing outside. And this one is humidity. Again, humidity outside is the top, humidity inside between 40 and 60 during the same month for the same building. And then, of course, we get the overall performance, which is the space heating demand, the actual energy that we need to keep that building at those temperatures. And you can see here that this is a population of 97 passive houses. The dotted red line is the modelled. The solid black line is the actual. So overall, performing exactly as modelled. And then finally, the not for retrofit point. Well, let's just go back to my criteria and what was comfort and health related and what was energy related. And I'd like you to drop out any that you don't want in your retrofitted house. Well, I can already tell you that it's none of them. Everybody wants those comfort factors back in their house for retrofit as well as they do for new build. And what you can see here is that all those criteria still apply for retrofit, for a passive house retrofit, as they do for a new build. And there's only a couple where I've got the slightly shaded stars there, where they're relaxed a little bit, and therefore you get a slightly different value. But overall, your surface temperatures, your overheating, your ventilation, exactly the same for retrofit. So you're getting exactly those same levels of comfort. So that's what we want. That's what you get in a new build. That's what you get in a retrofit as well. And the best way, I think, to dispel the myth that you can't do retrofit is just to give some examples of existing buildings. So we can't do old buildings with heritage features, can we? Well, here's one where we can. And you can see here, this is quite natural materials that we used in this one, and U values down 0.16, 0.17, and air changes well below the requirement for retrofit. And you can see that we've got a heating demand there of 12, which is actually below the new build requirement for passive house. What about terraces and old terraces? We can't do those, can we? Well, this is an example of where we can. Here, with this approach was slightly more fossil fuel oriented in terms of its the insulation types, so you don't have to prescribe to a particular kind of insulation, and we can see here that again this is met the targets for retrofit or passive house. And finally, we can't do buildings at scale, can we? Well, this is again we can, quite a difficult structure here, cross floor concrete frame, which ended up having a timber frame infill, low U values again, and this one is interesting because we actually got some post occupancy data which shows that the gas consumption that was modelled, the reduction was 76%, what was achieved was 73%. Humidity bang on at around 50%, and CO2 levels well within the indoor comfort ranges. And that is those are my 3 myths, hopefully dispelled.
Perfect. Thank you very much. Our next speaker is Nick Grant, whom I imagine many of you will know. Nick is synonymous with Passive House. Anyone who knows Passive House knows Nick and his no-nonsense, eco-minimal approach to sustainable design. He works as a freelance Passive House consultant alongside other specialists, and his current projects include housing, offices, an increasing number of archives, and museums. He's very keen on cost-effective solutions and enjoys building, detailing, and physically making things. And he is a founding director of the Passivhaus Trust. And Nick, you've got 4 myths and 10 minutes.
Great. So 4 minutes. Thank you. Great. Start with the easy one. And this has popped up in the chat. They don't need heating. They do. And we actually quite like conventional heating, like radiators. This particular house has got an air source heat pump and a radiator. The energy model on the left is just the heat balance. So on the left, we've got losses, on the right, the gains. You can see the little bit at the bottom is the energy for heating over the year. And it's under the 15 kilowatt hours per square meter per year, which is our target. And in real terms, this is actual monitored use. It came down to about £2.80 a week for heating for this house. And that's to keep the whole house warm and comfy all year, no problem. Example of a school, this is one of the archetype early Passivhaus schools, 2,400 square meters, really quite a small boiler, but as it says there, 4 times bigger than needed. And in the classroom, I put an arrow because you probably wouldn't spot it. There's a little radiator behind the door, so it's not taking up useful space. Even lovely, comfortable temperatures throughout the class. But as Rebecca said, if you want to open the windows, you can open the windows, not a problem. So since it's so little, why not go for 100%? Why not go all the way to completely solar, passive solar heating? And we tried that. I worked for Centre for Alternative Technology in the 80s, and there were lots of attempts to try and store those last little bits of heat in the winter. The problem is it's a really poor match. So the midwinter, when you've got the sun hardly comes above the horizon, there's not very much strength, you end up, it's really quite difficult to sort of mop up those bits. So if I was talking about passive solar, all my 4 myths, I'd have to say they all apply to the passive solar house. They do need heating. They do really restrict design. They are complicated and they do overheat. And so you'll hear about some buildings that don't need heating, passive house and non-passive house. And we'd say this is actually a bug, not a feature, because as you saw, we're so close to not needing heat. If you imagine internal gains were double, then suddenly the heating doesn't need to come on. But the problem with that is, how do you control that? If the house is already warm, all you can do is open the window, and that would be in winter when you've got cold drafts. And then what about summer? You know, the gains that are heating it, the hot water losses, the lighting and so on, they'll be providing uncontrolled heat at the time of year when you really don't need it. So that's not a good thing. And I've seen up in the chat, it's lovely to see, I wasn't even sure if this was worth putting in, this idea that the passive house is boring, it's all the even temperature, it's sort of, you know, just, yeah, it's life sapping. I've heard all sorts of things said. This idea of your house being too comfortable. in the 80s, with some French philosophy friends spending winters in extreme conditions, experimenting with thermal comfort. It was the 80s, we were young, we were stupid. I can assure you they all live in nice warm houses now. And no client has ever said this to us. We've never had anyone complain their house is too comfortable. This is just a complete myth. So I nearly didn't put it in, but I see it's appeared in the chat, so I'm glad I did. The idea they overheat, actually, yeah, hands up, passive houses can overheat. All buildings can overheat, with or without global warming. And passive house isn't foolproof. You can still get it wrong, but we've got some really powerful design tools with passive house. We've got the passive house planning package, some modeling tools. There's a Passivhaus Trust that provided guidance, spreadsheets to do stress tests and so on. The certification is a check. So we've got lots of tools to do that. And the passive house community are on the case, because this is, it's like a brand, it's not a brand, but we have this identified thing. That's why you're all here tonight, because we've got this idea we can talk about passive house. So if it doesn't work, word gets around and we don't have any more work and no more customers. So it's got to work. And cooling is allowed. You've got to do it efficiently, you've got to do it comfortably. And if you're in an urban heat island, in London, doing flats, say, then I think a small level of comfort cooling would be a really sensible thing to do. And it's perfectly fine. And it restricts design. So, okay, two options here. I could do the comforting lies. I could show you all sorts of crazy shit that is all over the place and meets the passive house standard with absolutely no constraints. But if we're seriously interested in the environment and cost-effective solutions and really dealing with climate change, rather than just delivering passive house to any requirements, then we have to consider a lot of constraints. And some of these are legal constraints, some of them are ethical, some of them are just practical things. And passive house adds a few more. So we've got this, we've got a heat limit, a heating demand limit, air tightness target, which frightens off a lot of people at first, but becomes very easy to do. And we've got a lot of comfort and health criteria, which have already been mentioned. So we've got some more constraints. I think constraints are really useful tools. Now, deeper constraint, which actually I'm going to say is a myth, is this idea that our passive house has to face south. We sort of teach this on the training course. Ideally, you face south, then we can do nice, simple shading for summer comfort control. But this example is south-facing. It's certified passive house. It's super comfortable. It's great, but not all sites have the luxury of this. Here's a project we had a couple of years ago. It's now been occupied for a couple of years. West-facing plot, lovely client, walking distance to the town in Bishop's Castle, but it's on a service plot with houses to the north and south. So we've stuck with this very unideal west-facing plot, and we sort of, gritted our teeth and bore it. And it turned out to be really good. Again, embracing the constraints. The challenge was designing to get good daylight and views without overheating with the low summer sun and the morning sun. And that's not a passive house problem, it's a house design problem. So you can see here the energy balance, that's 17 at the bottom. We had under 15 before. We're trying to hit 15. Bit tricky on this with this orientation. We could crank up the insulation, makes it expensive. We could get more solar gain, but then we get a summer comfort problem. So we designed an alternative target of the peak heat load. Bit geeky, some of you will know this stuff, but if not, you've got some of the joys you've got to come when you get into passive house. And out of that came, there was a bit more design effort to get the daylighting to work without overheating. But it turned out really lovely, and the client loves that they get the morning sun and the evening sun, super comfortable, and a similar, magically the same heating demand as the first example. These are much bigger than the example John gave us, 150, 170 square meters. So it's a decent sized house, under £3 a week to heat it to a lovely, comfortable temperature. And then finally, it's too complicated. So yeah, compared to what? So Ben Law, really lovely building, Grand Design's favorite. It's heated with logs from the wood, it's built with trees from the wood, and it's insulated with straw from the fields. Our own house, similarly done, maybe not as beautiful, but Welsh timber and straw, wood stove for heating, windows for ventilation. That was, yeah, we were seduced by that idea. Some of the alternatives to passive house that claim to be simpler actually end up much more complicated. They try and get rid of the MVHR and try and use heat recovery on stack ventilation. They create buffer zones, active solar, all sorts of stuff, which, and there's lots, if you Google alternatives to passive house, I think all the examples are more complicated, more difficult. If you find a simpler way of achieving the same quality and everything, then let us know, we'll bite your arm off. And as Einstein said, things have got to be as simple as possible, but no simpler. So our house, we had windows for opening. It turned out to be quite complicated to manage. So we retrofitted heat recovery ventilation after 20 years, and we were really really pleased to have done that. And there's still room for simplification. We've got some rules of thumb. Passivhaus Trust have provided some guidance. There's a friend in Vancouver, Monty Paulson, some of you may know. He's done a series of workshops on pattern language for Passivhaus, identifying sort of cost-effective solutions. And designing for the peak heat load I mentioned, which will mean nothing to you until you get into Passivhaus, but the heads up, that's a useful simplification. And just a few random examples of projects I've worked on, just show a range of projects that have embraced the constraints. There's some rural social housing. A lot of my projects are rural. This is George's house already mentioned, and he's with us watching tonight. Lancaster Co-housing early project. St. Loy's nearing completion in Exeter with Archetype. The one showed earlier, Hope View House. Something that's it's not certified, but it's certifiable. Another not our typical passive house. Some challenges, but meets the standard. More low-cost rural housing. Typically around about £1,000 a square metre, we're delivering this sort of thing to lock up without bathrooms and so on. Benefit Architect's Office, another example by friend Charles. Archetype's archive building at Duxford, which I'm involved with. And Agar Grove in London, one of the few urban projects I've been involved with. And if it is too complicated, don't blame Passivhaus. It's down to the architecture, it's down to the building services. There's no reason that Passivhaus has to be complicated. But when we hear challenges about it being too complicated, it's usually not Passivhaus itself. So the two key ones is kind of a challenge for you to take away and deal with, really. Yeah, try and make stuff embrace the constraints and try and make it simpler. Thanks, I talked a bit quick. I think that's it on time. I'll just leave you with that quote to digest, which is kind of, for me, the key to design. Thanks for your time.
Thank you, Nick. So I wanted to go back to this question of clearly, in terms of operational carbon, reducing energy use, you can't beat Passivhaus. That is clear. It does exactly what it says on the tin, reduces operational energy. But can we come back to the question of whole life carbon, and how does it look at that in terms of just, for example, a simple question, which I know is another one of these myths, but maybe you can set us all straight. If you're really looking at embodied carbon as well, is triple glazing the way to go on every Passivhaus?
I thought Rebecca was going to have a slide on that.
She mentioned it very, very quickly, but I think it's worth kind of drilling down, not just on the triple glazing example, but the whole principle of, you know, these more complex triple glazed windows have complex frames. I mean, there are a lot of things that will drive the embodied carbon up, I would think. It's a question.
Okay.
Who wants to tackle it? Who wants to answer? John?
Okay, so the question of embodied carbon. So at the moment, the Passivhaus standard does not include any requirements for embodied carbon. So you can build your Passivhaus out of sticks, or you can build out of steel, and as long as the equation, the numbers work, then you've got a Passivhaus. And that might change in the future. There may well be some embodied standards starting to come along. But the crucial thing is that most of the time, the things that we are driving to achieve with Passivhaus actually help your embodied carbon budget, your bill, if you like. Because most of the time we're kind of for simplicity, because simple shapes are easier to build and they have fewer thermal bridges. They're more compact and efficient from a form factor point of view, so they're using less energy, and you're also more likely to achieve good air tightness. So those are those simplifications, and using very efficient form factors are the sort of things that are pushed really early on a Passivhaus project. And 9 times out of 10, what they will also do is result in a lower embodied carbon bill because you're using less materials overall. So that's the first thing. The second thing, the triple glazed windows myth. So where do your windows come from? Because they're going to have different embodied carbon bills depending on where they come from. And actually, the figures that we've looked at is that overall, how long does your building last for? What's your saving going to be? Is it over 20 years, 30 years, 40 years, 50 years, 60 years? There's lots of variables in trying to make that assertion. But I would first of all contend that actually that's not true, that overall your triple glazed windows over their lifetime, the lifetime of that building, will actually save you more carbon than went into the extra pane, the third extra pane and the bit of extra materials. But that aside, you're missing the point. Those triple glazed windows are in there for other reasons as well. They're in there because they're going to give you internal surface temperatures above 17 degrees at all times in the year. So when it's freezing outside, it's going to be 17 degrees or above on your inside of your glass. That means, as Rebecca mentioned, it's going to feel comfortable inside your house. You're not going to feel those radiant cold temperatures that we've all felt sitting next to a double glazed patio door when the heating's on and you're feeling a bit chilly, or even when you come down in the morning and there's a little web of condensation on the edge of your double glazed patio door or your double glazed windows. Those are the things, in addition to the heat loss, that your triple glazed window is achieving for you. So it's not only about the energy and the carbon.
Okay, let me ask it a different way. You and I had a fascinating conversation a couple of weeks ago where you were describing some of the work you're doing for Letty and looking at how many houses have to be retrofit in the next decades and how we're going to do all this. How are we going to, if you multiply this whole process of Passivhaus, is this approach the answer across the board, or do we need a variety of approaches?
Okay, so the Passivhaus building physics principles apply to any building. They work, and they have been effectively the dials have been pushed to certain points for each of the criteria that make it a Passivhaus new build, Passivhaus classic, or a plus or a premium. Passivhaus retrofit standard is NFIT, and the dials have been pushed to a certain point on there. And if you do that, you will achieve a very high performing, very low energy building. Is that right for every building in the UK? And will we reach every building in the UK in terms of retrofit? Probably not, but the same principles apply. And one of the things that people don't often understand is that there is a component alternative for the NFIT approach, for the Passivhaus retrofit approach, which actually is misnamed. It's more of an elemental approach. And what that's for is when you do have these really difficult to treat buildings that you're not going to be able to eliminate all the thermal bridges, or the orientation of the glazing is just not going to be sufficient to get that building to be as high performing as what we would like to for Passivhaus. And in that case, you apply the elemental approach and you go for good U values, good performing components, and you get, again, a very comfortable, high performing building, but it won't necessarily reach those very low levels. So it's really what's appropriate for the building, but building physics is appropriate for every building, and the principles behind comfort and health are also appropriate for every building. And I think that's what we'd like to get across.
Yeah. Because related to this question of the triple glazing is the whole question of adaptive comfort and whether temperature swings, whether we allow more temperature swings. So just put a jumper on or to wear a t-shirt in the middle of summer. How do you?
Okay, so let
what's
me
your take on that?
Let me turn your question back at you. So
yeah.
We've got many of the pictures we saw tonight were sort of pioneering Passivhaus buildings from some great people who wanted to push the boundaries. Obviously, we're now getting more mainstream, but if I'm answering your question, which is how do we sort this out for the entire building population in the UK, that means retrofit. That means getting your average person to do this and to then live in that building. And the evidence shows that you cannot expect those people to put on an extra jumper. They will live in their house how they see fit. And what we need to do is build the building around that as to be as efficient as possible to allow them to do that. And when we are in a very efficient house, close to Passivhaus levels, and you turn the temperature up by 1 degree, that's going to make very little difference to your heating bill or to your energy demand because it's so low to start with.
Okay, let me take some questions from the chat. There's a question about OSB board, the use of OSB board, known as an off-gassing VOC material. So what's your take on, I mean, you've really stressed how great it is for indoor air quality, but it doesn't really address using, or does it address, how does it address healthy materials versus some of these other less, shall we say, less healthy materials? Who wants to take that one? Nick?
I was going to say Rebecca.
Rebecca.
I'll start.
Yeah, not being shy. I'm just.
I mean, I know Archetype has done a lot of work on natural materials. So what's your take on this?
Yeah, we have done a lot of work on natural materials and do favour them where we can. And in the case with OSB is that it is a very small percentage of the whole makeup of the building, and we're using soft timber and recycled newspaper elsewhere. And it's one of those things that you kind of have to weigh up if we want to be using Passivhaus at scale and getting contractors and clients on board. That is one of the options that is favoured. And there's a little bit of off-gassing in the materials that are used to make OSB, but in passive houses, with that sort of the high turnover of air that you get from your MVHR unit, any sort of VOCs, that they're not hanging around. Whereas you still use those materials in a standard house, like most kitchens are made from those materials, or your IKEA furniture.
Absolutely, but we need to be moving away from all of that.
Exactly, well, absolutely.
Yeah.
And yeah, OSB is not the only material by any means.
Right, well, OSB is an example. Okay, let me move on to another. This is a question from Scott McCauley. Out of curiosity, has any research been done on scaling up training for contractors and design students to upscale capacity for delivery so that we can hit our climate targets as part of a countrywide Green New Deal agenda? That's a more general question.
I don't know if any of us can answer that. I just chip in to say that I don't see the problem of being contractors. We need to, us as the designers that need most of the education, because we need to design stuff that anyone can build, whether it's a factory or on site, whether it's brickies or factories. So yeah, I haven't come across a big problem. Occasionally you get problems on site, but generally it's design is the biggest challenge for me. So educating ourselves as the design team. Yeah.
So I just say that, yeah, work is in progress on both of those, and we're looking to expand the contractor course that is already out there, and we're also looking to get into several or many universities into the architecture courses and getting in Passivhaus modules so that people very early on in their architectural education understand what this is about.
Well, that raises another really interesting question that came up in one of our discussions as we were preparing for this earlier this week, which is clearly, as designers, we need a better grip on building physics. I mean, when I studied architecture, there was a lot on passive solar and climate responsive design, but nothing on building physics. And I was in a very technical school. That is changing, but I think is the need for Passivhaus the failure of the architecture curriculum is a question. I mean, is it about learning building physics, or is it specifically about learning Passivhaus? And certainly learning Passivhaus, I haven't done it myself, but everybody says, you get the grounding in building physics through that. I don't know if you have any view on this, or maybe Rebecca, since you're trained as an architect, what you think. I mean, should every architecture student have a Passivhaus course now, or should it be an option?
Yeah, I think so. I think that would be great. It's like you've mentioned, that upskilling of the designers is a really big problem, and maybe not be great if everybody could be architects and Passivhaus designers, but I think having that base in building physics, as you mentioned, I think is really vital, because those principles then can be applied to many different things, and just sort of making the good improvements that we do need. And currently Passivhaus is the only thing that kind of captures that building physics and the quality and third-party assurance at the same time. But yeah, I think education is a really big, important thing at the moment.
I'm going to come back to a couple of really straightforward questions, because I know we have a huge range of expertise on this call, on this program. So if you're an architecture practice wanting to do your first passive house project, what external support would you recommend?
There's the Passive House certifiers who are there who can provide that support to architects, as well as doing the certifying. They also have a consultancy, and there's plenty of consultants here who I'm sure are also willing to provide support to architects wanting to give it a go for the first time.
I would suggest you read about how Mikhail Ritchie's approached Goldsmith Street, which has been quite, I've written about it, others have written about it. I mean, it was designed as a passive solar scheme, and then they wanted to turn it into a passive house scheme. And there were a lot of things they had to do with detailing, to do with sizes of windows, all sorts of things. And they worked with Warm Associates and through a very iterative process. So they brought in specialist support, which for a small practice, may be challenging, but there are individual consultants out there who I'm sure would be happy to help you. I think you need to study yourself as well as hiring some expertise.
I would say, Hattie, that one of the characteristics of the Passive House community is it's very open. I'm very
absolutely very generous and very supportive, and there are all sorts of forums, and I mean, you know better than I, but extremely generous and transparent at sharing information.
So it's all out there. There's no hidden font of knowledge that's kept away from people. So if you're getting into Passive House for the first time, there's so much stuff out there that you can start with before you need to actually start paying a consultant. And even then, people are very willing to share their knowledge.
We've got a couple more questions related to opening the windows again. This is such a confusing topic. What happens if the occupant opens a window when it's too warm outside?
You'll get a bit warmer. It's the same in any house.
It's counterintuitive, though. That's the thing.
I know it's not intuitive. It's the same in any house. If you're in a hot climate, if it's cooler inside and you shut the windows, you'll stay cooler. At some point, you get a bit warm, and you'd rather have warm air blowing over you than be sat in a slightly cooler but still air. But then the house will warm up, and it'll be warmer at night. But yeah, it's like in the car. If you put the air conditioning on, it works with the windows shut, but not with it open. But you can, if you rather have warm air blowing over, you can do that. But it's physics again. I mean, a lot of it, I think the key thing, it is just physics. But we could invent another one and brand it something different, or not call it Passive House. But apart from the targets, which, the energy target and the air tightness targets, which are specific numbers, we could have a slightly different number, but everything else is just physics. Same with that.
So I've got one more question here. If you open the window in the summer, do you need to put the MVHR on standby?
No. It really is not very difficult. Just if you want the window open in winter, the Norwegians sleep with the window open at night in winter when it's -10. You can do that. Shut the bedroom door unless you want to make the whole house cold. But yeah, don't overthink it. It's easy.
I think one of the misconceptions of MVHR is that it's most people's experience of mechanical ventilation is what you see in an office, or what you experience in an office, where it's perhaps noisy, forced, coming out all the time. MVHR is completely different. It's effectively a trickle kind of ventilation in the background, completely silent, and if you open the window, nothing happens. There's no pressure differential. The MVHR carries on trickling away in the background. When you shut the window, it carries on. It's easy, as Nick says.
It's been great watching the chat, because there's a lot of experts in the audience who are answering stuff. It's yeah.
Well, I think ACAN is planning. I'm not watching the chat because I'm reading the questions, but I think ACAN is planning to take this away, and you're going to have the chance to answer all these questions, and then it will be distributed to everyone who's signed up.
Yeah, we're hoping that the good speakers will answer, and we will just do the sharing of all of their wonderful knowledge.
Right.
Can I just say that we're going to share the second poll just to see how people's opinions may have changed throughout the event. So if everybody
What was it on the first one? Can you put the first one up again, just so we remember?
Oh, that's beyond my technical capabilities.
Okay,
Let me
all
see
right,
if I can
let's go.
find it.
Sorry.
I'm sure we can share that.
I'm on it. There we go. So that was poll 1. So we were 42% were big fans and
Right.
only 2% suspicious.
And not a
Right.
single, not a fan, not even one. So there's still some suspicion, but a whole lot of fans, a whole lot of big fans of this now.
I think some of the discussions are quite frustrating because they're quite academic, and I think a lot of it gets answered if you actually visit a place, go and kick the tires, you know, stay in one, live in one if you can. I mean, it's not always possible, and it's obviously trickier under lockdown. A lot of people do open their houses for Passivhaus open days, or just, you know, let some towns and cities have low energy open days and various things. So often people will open up their houses.
I think that's very good advice. Yeah, that's very good advice.
People will tell you, you know, what worked, what didn't.
Okay, we've got another question here about about social housing. Building social housing to Passivhaus standards differs from building a private house because of the absence of choice. How would you go about supporting residents of a social housing scheme to understand how to run their homes?
Well, I think that the first point, which is one that Nick made earlier, is that if your passive house is complicated, don't blame Passivhaus. You've made it that way. And that applies in any kind of passive house. So the MVHR for social housing may well be centralized. It may be external to the individual units. So the occupants never have to get involved with servicing. That can be done external to the building. And they may know they're living in a passive house. Other than that, you know, there's no special manual required, I would say. It can be made extremely simple.
In the early days, we spent quite a lot of time trying to come up with standard manuals and things that people could use and so on. But the thing is, as John said, to try and make it easy to, we like stuff. I never read a manual personally. You know, you get stuff and use carefully before reading a manual is my motto. Sometimes ends in disaster, but yeah. Houses should be like that. We shouldn't have to learn too much. But some things are counterintuitive, like the opening the windows, shutting the windows. And they say it's not a passive house thing. We had people move into one of them, the Bishop's Castle one, the east-west facing one. They were opening the windows in the day and then closing them at night. And it got a bit warm. It wasn't too bad. They just said, oh, it's a bit warm in summer. We said, are you opening the windows at night? And they said, oh, no. And then they changed it and it was easy. But, you know, that would be the same in any house, you know, over a heat wave.
Wow, we've got loads and loads and loads in the chat. Here, someone is saying that the London Borough of Camden has prepared an accessible how-to guide for their residents for Agor Grove. So that could be an interesting place to look. And I'm sure they have something at Goldsmith Street. I know at Carabrook Meadow in Norwich, Sarah Lewis prepared a very simple manual explaining there are only 14 units there. And she spent quite a lot of time with residents to be sure they knew what was what. I think that we can move on to the virtual pub. I think this has been a really interesting, worthwhile discussion. I don't know, would each of the three of you like another 2 minutes to have a final word, or are we good?
So just get out there and visit stuff, you know. It's, and if you're serious about climate change and all this other stuff, yeah, just we've got to solve this, and it's got to be normal. It's got to be easy, and it's got to be cost effective, and it can't be a premium product.
Yeah, and it shows this event and all the chat that we've had have just shown how much interest there is. And I think, yeah, like visit things and just talk to people. There's so many people out there who are so interested, and everyone who I know who lives in a passive house is super willing to share all their information and has great blogs and websites and is willing to chat to people.
John?
I'd just kind of go back to my car analogy, in that, you know, the people in this country they're used to poor quality housing, or I won't say poor quality, but poor performance housing, buildings that do not perform. And we put up with it because we've never known anything different. And I think we need to get the message out there that there is an alternative, and it's not particularly more expensive, but it makes a massive difference to your quality of life.
So I now see a link to the pub in the chat, and lots of useful information in the chat. Sara, do you want to say a final word? I thank everyone who has joined. It's really fantastic to see so much interest. And thank you also to the Passivhaus Trust who have supported this event, and to the fantastic organizers at ACAN.
And thank you, Hattie, for stepping in and chairing for us. It's been really great, as usual, to have everybody's support for the event. So thank you all very much. And yes, please do come along to the Hope and Action pub for a drink if you like it. The link has been shared, but it's also in your Eventbrite in your emails. And hope to see as many of you there as possible. Thank you, everybody, for your contributions.
Have a good rest of the evening.
Great. Thanks all.
Thank you.
Thanks, everybody.